Assalamu alaikum. I hope you are safe and I hope seeing you soon on the chair of our school. The first chapter for grade 12 SE is titled Work and Energy. The main objective of this chapter are determine the work done by a constant force, determine the work done by the weight, calculate the kinetic energy, the gravitational potential energy, and the mechanical energy. And the last objective is apply the principle of conservation of mechanical energy. First, let's define a constant force. We know that a force is a mechanical action exerted by a body on another one. So we can define the constant force as a force that has a constant magnitude and a constant direction. For example, here we have a force is equal to 5 Newton and it has a unique direction and it is directed horizontally to the right. So, what is the definition of a work done by a constant force? May someone say it is a physical effort, but the question is, what is in physics the definition of a work done by a constant force? To define the work, let's discuss the following example. We have a car and we want to displace it to the left. So for sure we have to apply a force in the direction of displacement. Applying a force allows to transmit energy from a person to the car, which result in motion of the car. So the work is a method of energy transfer. When a force performs work, energy is transferred from a body to another or transformed from a form into another. To more understand this concept, let's consider the following example. We have a book on the left of a table and we want to displace it to the right. We have to apply a force. But if the force is perpendicular to the direction of displacement, we can see there is no displacement and therefore there is no work. So we can say that if the force is perpendicular to the displacement, the work done by this force is zero. To displace the object, we have to apply a force in the direction parallel to displacement as shown here. So if the force is parallel to the displacement, there is a displacement and therefore there is a work. The expression of the work done by a constant force in the direction of a linear displacement is defined as Wf is equal to F times d. The expression of the work done by a resistive constant force is Wf is equal to minus F times d. The SI unit of the force is in Newton and the SI unit of the distance or the displacement is in meter and the SI unit of the work is in joule. The work of a force is an algebraic value. That means it can be positive or negative depending on the nature of the force. If the force is motive, that means in the direction of the displacement, then its work is greater than zero and the system gain energy. If the force is resistive, that means it is directed opposite to the direction of the motion, then the work done by this force is negative and the system lose energy. And if the force is perpendicular to the direction of the displacement, then the work of this force is equal to the zero and the system doesn't gain or lose energy. Let's solve the first application. We have an object that displaced from point A to point B along a horizontal rough surface under the action of a pulling force. We have to determine the net work or the sum of work of all external forces. First, we have to determine the external forces and to draw them on a free body diagram. We have four forces. We have the pulling force that is directed as motion. We have the friction force, it is directed opposite to the motion, and we have the weight and normal are perpendicular to the displacement AB. The work done by the pulling force is equal to F times D. From the given, we have F equal to 10 and the displacement is equal to 100 centimeter. We have to convert it into SI unit into meter, so we have to divide by 100, so it become 1. So the work done by the pulling force is equal to 10 times 1 equal to 10 joule greater than 0. So we can say that the work done by the pulling force is motive work. The work done by the friction force is equal to minus F times D. We have F is equal to 5 and the displacement is equal to 1 meter. So the work done by the friction force is equal to minus 5 joule. It is less than 0, so we can say that it is a resistive work. The work done by the normal force is equal to 0 since it is perpendicular, and the work done by the weight is also equal to 0 since it is perpendicular to the displacement. So the net work by all external forces is equal to their sum. So we have 10 minus 5 plus 0 plus 0, we get 5 joule. Now we discuss the second objective, the work done by the weight. We assume that the weight is a constant force. We consider an object that moves on a curvilinear path from A to B, as shown in this figure. To determine the expression of the work done by the weight, we apply the formula. The work of the weight is equal to the weight times the displacement distance, AB vector. But we can say that AB vector is equal to A prime plus A prime B. So we multiply the weight by each term, we get mg vector times A prime plus mg vector times A prime B. But A prime is perpendicular to mg, so this term is equal to 0. So the work done by the weight is equal to 0 minus mg times A prime B. Here minus because mg is downward and A prime B is upward. But the distance A prime B is equal to HB minus HA, so the expression of the weight become minus mg HB minus HA. We introduce the minus sign to the parentheses and the expression become mg HA minus HB. But A is the initial position and B is the final position. Therefore, the expression of the work done by the weight is equal to the weight times the initial height minus final height. Let's solve application 2. We have a box that displays from A to B along an inclined plane. We have to determine the work done by the weight, knowing that the mass of the box is equal to 5 kg and the height of point B is 100 cm. We apply the expression of the work done by the weight, which is equal to mg times HA minus HB. We substitute, we have mass equal to 5 kg. The intensity of the gravity is 10. The initial height at A is equal to 0 and the height of B is equal to 100 cm. We convert into meter by dividing it by 100. It becomes 1. So the work done by the weight is equal to minus 50 joule, less than 0. In this case, the work done by the weight is resistive work. At the end of the first part of this chapter, we can summarize the main point as: the work done by a constant force is the amount of energy taken or given to a system that results in a displacement under the action of a force. The expression of the work done by a motive force is equal to F times D, and the expression of the work done by a resistive force is equal to minus F times D. If the force is perpendicular to the direction of the displacement, then the work of this force is equal to 0. And if the work done by a force is greater than 0, then we can say we have motive force or motive work. And if the work done by a force is less than 0, then we can say we have a resistive force or resistive work. And the expression of the work done by the weight is equal to mg times h initial minus h final. Thank you for listening this video and doing all the recommended assignment.